Okay, in this question we have a function that represents the height in centimetres of a cylindrical tin can with diameter x. So here's our function hx equals 640 over x squared plus 0.5 for the domain 4 is less than or equal to x is less than or equal to 14. Find the range of h. Now the best way to do this is actually to draw a sketch. So we're going to go menu 5, and what we can see is I've put the equation in already. Here's the function, and I've put in the domain as well from 4 to 14 here. Okay, so we press execute and then we'll just draw that. Now what's happened is I've left the view window the same from the last time. Now bear in mind it's from 4 to 14. We can change our x min from, let's make it 3, just one less. And then let's make this one 15, one more, and we'll probably make our scale 2. Okay. And then the y min, if you put 4 and 14 in, we'll get 3.77 and 40.5 out. So let's put a y min of, I don't know, let's put 0 in and put a y max of 45 in. And then let's make a scale of 5 for that one. Okay, press execute and draw that. And you can see we've got our graph, and it just seems to be going down from here to here. Actually, I'm just going to change the view window slightly just to, because the labels are getting in the way. So I'm going to just make that 17 and draw that. And you can see the labels now. You can see the graph starts and ends here. So actually, we could have just put our lowest value in and got this value out, and we could put our highest value in and got this value out. So if we trace from here, we can see that we go to the end, the maximum value is at 40.5, and you go to the other end, we can see our minimum value is at 3.765. Okay, so therefore our range is going to be h of x, all the possible y values we can have on this graph. So h of x has got to be greater or equal to, it was 3.765. Let's just write 3.77 to 3 significant figures, and less than, what was it, 40.5 I believe it was, to 3 significant figures. Okay, from our graph. And in high-level A&I maths, that's all you need to do for your working. Now, h minus 1 is the inverse function of h. So to find h minus 1 of 10, what we do is we can make hx equal to 10, and that's what our function equals, and then we can reverse all of this to find h minus 1. So we take away 0.5 to get 9.5, gives you 640 over x squared, times by x squared and divide by 9.5. Most high-level A&I students should be able to do this, and then you just got to square root that answer to find the inverse. So if you go to menu 1, you see I've calculated this already, and I just put it into the inverse function, worked out the inverse function, and I got 8.207. So 8.21 to 3 significant figures. In the context of question, interpret your answer to part B, part 1. So this x value, okay, is the diameter of our tin. So we have a tin diameter of 8.21 centimeters, and its height is equal to 10 centimeters. Okay, that's our real world context for this question, and that's what it's asking for. Now the next part, write down the range of h minus 1. Now the range of the inverse is equal to the domain of the original function, and the domain of the inverse is equal to the range of the original function. So this will be the domain of my inverse, and this is the range of my inverse, the domain of my original function. So the range of h minus 1, so we know that h minus 1 of x, b part 3, h minus 1 of x must be greater or equal to 4 and less than or equal to 14.